So in part G, you're supposed to make your probability distribution into a histogram. So remember, we always put our probabilities vertically, and then we put our random variable x, but I should put what this actually stands for. So x is the number of activities of a randomly selected student. So number of activities. I am going to use an axis break because it is possible to have 0 activities. So I'll have 0, 1, 2, 3, 4, 5, 6. And then the highest probability was 34%. 2, 3, 4. So I'm just going to count by, there we go. And then I'm just going to have each bar kind of have the x value as the midpoint. So I'll have one bar with 0 in the middle, and it has a height of 34. Yep, there are the annoying kids. No. I'm sorry, but you're going to survive. I can't deal with it right now. Go. So anyway, don't have kids, children. Anyway, so we have that height, and then 25%. I don't remember what the others are. 15, 6, 5. 15, 6%, 5%, 8, and 7%. So those last two kind of mess up the general trend, but for the most part, we see this very slow descent. So the shape is skewed. Remember, whenever you're trying to figure out left or right, yes, most of my data is here. That's where the peak is, but the skewness describes the direction of the tail. The tail is pulling to the right. And technically, you should also include it's skewed right with a single peak at 0. So because it's skewed to the right, remember when we used to do this in Unit 1, I would always talk about my age, and I would talk about how the average of our class is about 17 or 18. The median of our class is about 17 or 18. But if I'm included in the class because I'm so much older than you guys, I wouldn't change the median. It'd still be about 17 or 18. But suddenly the average gets way drawn up. So your mean always falls in the direction of skewness. So if this is skewed right, the mean will be pulled further to the right. So I don't want to use x bar. The mean of our random variable x will be further to the right than whatever the median of the random variable x would be. So we can predict that the median is probably smaller than the value we found in part D. So it's going to be smaller than 1.75. And that's because, like I just said, the mean falls in the direction of skewness. So I apologize that these answer keys took so long for me to make, well, that I just straight up forgot about them.